Hi everybody and welcome back. Okay, so today what we're going to do is we're going to talk about we're going to take this factoring form and we're going to take it one step further. So we've been doing fairly straightforward ones the last little while. We've been doing ones like this, for example, where we just have to think, okay, what numbers multiply to make that number that add to make this number, and we would put the 6 there and we would get a 2 and a 3 hopefully, and put minuses on both of them because we need minuses on both of them in order to get -5. And then we're going to multiply those two signs, ask ourselves, are we getting this sign? If we are, we've got the right numbers, the right signs, and we just write out our factors. Okay, but not all factoring situations are quite this straightforward. So what happens if you get something like this? 2x squared minus 6x plus 4. Now a isn't 1, is it? Okay, all the ones I've been doing up to this point, a has been 1. So the thing to recognize is whether or not the three terms that you're looking at have something in common, have a factor in common, okay? These numbers are all divisible by 2. So if I take out the 2, if I factor out the 2, I have that. Now a is 1, okay? This 2 is just going to come along for the ride. Because a is 1 now, I can factor the way I've been factoring before. I take this number, which is 2. I look at which numbers multiply to make 2 and add to make 3. 2 only has one pair of factors, and that's 1 and 2. So if I now put negatives on both of those, when I add those two numbers, I'm getting -3. When I multiply those two numbers, I'm getting 2, a positive. So we don't worry about this number, we worry about the sign, and we'll see in a later video why it's the sign that's important, not the number. Okay, so now what we do is we keep the 2 because this is part of our expression, and then we write out the rest of it. And we're done. Okay, so that's one that we'll do. Then the next one, 3x squared plus 12x plus 9. So here we've got a common 3, right? So we take out the 3, and it gives us x squared plus 4x plus 3. So if you have trouble with division or with multiplication, work on your times table. It's really good to have that memorized up to 12 times 12. If you're wondering whether you factored this step correctly, it's very easy to mentally go through and multiply it back out so that you see whether or not you come back here. So here we would use what's called the distributive property of multiplication. This 3 has to get multiplied by everything that's inside the brackets. Okay, brackets mean multiply. It's actually what they mean, okay? So if we multiplied it out, we would have 3x squared, this times this, plus 12x, that times that, plus 9. And of course we don't want to go in that direction, but sometimes it helps to think, okay, if I take out the 3, what would I have to multiply 3 by to get 3x squared? And because the answer is x squared, you know that that's what goes inside the brackets in that position, okay? So now this is of the form we've been working on. It's of this form again where a is 1 because a is now 1, it's right here. And we're just going to take the 3 and get a 1 and a 3, which multiplies to make 3. When they're both positive, they add to make 4. When we multiply the two positives, we get that plus sign there, which is what we have to have. And so those are the correct numbers to factor that trinomial. Oopsie. And x plus 3. And you're done, okay? Next one we'll do is 5x squared plus 40x plus 60. So as we'll see in a later video, if you don't notice that there's a common number between the three, a common factor, it's not the end of the world. It will make your job easier if you notice that it's common, that there's a common factor, because then the numbers are smaller, and smaller numbers are always a little bit easier to work with than bigger numbers. But we'll leave that for another video, and for now we'll take out the 5 and we will get that. okay? So again, multiplying it out would get us back here again. So it's a good way to check if you're uncertain or if you're just getting started with this work. And now the 12, we're going to use 6 and 2. When they're both positive, we get plus 8. When we multiply these two signs, we are getting the positive that's in front of the 12. So they're the right numbers. The 5, don't drop it, don't lose it. It comes along for the ride. Okay, so there's that one factored. All right. Now, here's a little twist. X cubed plus 18x squared plus 72x. All right, well, what's with this cube business, eh? So this time we have a common x in each term. So if we factor out the x, then we've got that same trinomial look that we've been working on all along. The x comes along for the ride, just like the 2 and the 3 did and the 5 did in the last examples. And we just factor this as we normally would. So we take the 72, and again, hopefully our times table is strong, and we know that 12 times 6 is 72, plus gives us plus 18, multiplying those two signs gives us this sign, so we know that we've got the right numbers, the right signs, and so we just write out the factored form. There, okay? Now we will look at yet another twist in the proceedings here, and we'll look at this one. So there's a couple of problems with this one. The main one being is that it's just not in the right order, okay? When we're factoring trinomials, they have to be in this order. There are some very minor exceptions to that, but factoring trinomials of the form ax squared plus bx plus c, whether a is 1 or not, doesn't matter. They have to be in this order, okay? Otherwise it's just too hard to do. So the first thing we do, step number 1, is to rewrite it in what we call descending order of power, all right? So what I mean by that is that this is a polynomial of power 2, and that's because the 2 is the highest power in any of the variables. So this is the correct order. Notice that the signs that are in front of each term carry with the term. Now I don't have a plus in front of this 16 because it's the leading number up here, it's the leading term. There's no reason to put a plus in front of it. If it was negative, yeah, I'd need a negative there, but it's positive, so I don't need to put a plus here. But when I move it behind this term, then obviously it needs a plus, okay? Now again, I never, ever, 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 ever factor anything that's got a leading negative. It simply isn't done, okay? There are literally no exceptions to this. So to get rid of that leading negative, we're going to do this. We're going to factor -1 out of this entire expression, okay? And when we do that, of course, all the signs change because factoring is division, and when we divide something by a negative number, here we're dividing by -1, all the signs are going to change. So the x squared is now positive, the 6x is now positive, and the 16 is now negative. Now what we've got is we've got this look again. So now all we have to do is take the 16, think, okay, 8 and 2 will add to make 6. This one's got to be positive and that one has to be negative. When we multiply those two signs out, are we getting this sign? Yes, we are. Don't worry about that one. This one is not relevant anymore, okay? It's not to say you can drop it. You need to keep it, but it's not relevant in terms of thinking about your pairs of factors, all right? Keep the -1 and write your factors out. And you're done, okay? So that's that one. And 2 more here. So 3x minus 2x squared minus x cubed. Okay, now this one has elements of both of the examples that we've just done. So first of all, what we're going to do is get it in the right order. This is degree 3. This is a cubic, all right? So we're going to take the terms and put them in the correct order first of all. Now what we want to notice is two things. Most importantly, we have a leading negative. That's no good. We can't factor things with leading negatives in place. We need to get rid of them. The other thing we want to notice is that there's a common x. I can take both the leading negative and the common x out in one step. So I'm going to take negative x out, and what I'm doing is dividing each of these terms by negative x. So what I'm left with here is x squared. What I'm left with here is 2x, and what I'm left with here is minus 3. Okay? That's all there is to it. And now this 3, again, okay, so now we've got this again, don't we? Right? So we take the 3 and we say, okay, 1 and 3 add to make 2. That's got to be a plus, that's got to be a minus. When I multiply those two signs, am I getting this sign? The answer is yes. So these are the correct numbers and signs to factor that trinomial right there, okay? And this, if you were to multiply it all out and rearrange the terms and so on, you'd get right back here again. And this one is going to be 8 plus 7y minus y squared. Okay, again, same problem that we've had in the last few examples. Wrong order, so start by getting it into the right order. And then get rid of that leading negative. We can't work with that leading negative. Okay, again, it's just going to come along for the ride. We're not going to forget about it. We're not going to drop it because it's part of the expression, and to drop it would be wrong, would be algebraically, mathematically incorrect. So we're going to take that 8, that 8, and 1 and 8 probably going to be the right numbers, right? So this has to be a minus and that has to be a plus in order to get negative 7. When we multiply those two signs, are we getting this sign? The answer is yes. And so those are the correct two numbers and signs to factor that trinomial.